Good morning, everyone. I say morning because it is morning in London. It is morning in Germany and Switzerland, where our panelists are, and afternoon in India, where Mr. Pal is joining us as well. You might have participated last week. Thank you very much if you are with us this week as well. I am simply going to give you the agenda for today. We will recap a few things from last week, but not too many. So bear with us if you were a participant last Thursday. And we will concentrate more on the DRM for large area coverage and DRM for local regional coverage. And you will see why DRM is absolutely the best standard for both these requests or needs. And we will have a look in more detail at the single frequency network, a great advantage of digital, which is not there for analog. We received over 60, 70 questions last week. Many were referring to receivers. So please stay with us because we will have a session on that. And we promise that this will be a very sort of practical webinar. And at the end, you will have a chance to see how actually a digital transmission is put together, how easy it is, and what you can do with a content server, the key piece in the digital transmission chain. So stay with us. The best bits are both at the beginning, in the middle, and at the end. So here comes the quick reminder. I will just take a few minutes. As I said, we are a not-for-profit organization. A technology consortia exists everywhere for any new technology, so this is nothing new. We are not-for-profit, which means that we do not sell transmitters, we do not make receivers, and we do not solve countries' problems. Some people come to us and say, when is the consortium going to give us the receivers? Well, we do not do that. So what do? We publicize the technology, like this webinar. We support with objective and knowledgeable information. And we want to create a community of DRM experts, technologists, supporters, and enthusiasts. The consortium is open to everyone, whether you are an individual or company. So, who is a member of the consortium? We have over 100. Here are just a few names. You might recognize some international names. Others are local. Bessel, India. I'm looking very quickly, All India Radio, then Kintronic Lamps, that's antennas in the States, US Agency for Global Media, United States, Gospel, receiver manufacturer in China, and so on and so forth. You can have a list of all the members on our drm.org site. Why use the DRM standard? The standard is universal and gives free access to information, education, and entertainment. It absolutely gives you a chance to give information to everyone, no matter where they are, all the citizens in a country. It's very useful because DRM is one single technical standard for all bands and all needs. I was reading this morning an article saying, I won't mention the standard, saying it's the best for India. No, the best standard for India is DRM, and because it can do medium wave, it can do short wave, it can do FM. It can cover this huge country. So think very carefully before you decree or you choose the best standard for a country. DRM uses spectrum efficiently, is green, uses less energy than analog, and it creates a media hub. There has been a lot of discussion in these COVID times about education, how we educate children, and everyone says, oh, they will watch TV or they will go on the laptop. Well, a quarter of the world doesn't have internet broadband. A lot of people have no electricity, let alone water and soap to wash their hands. And radio is really the platform that can combine all the benefits of internet, of other platforms, very well paid, in an easy and accessible way. Introducing digital, of course, creates jobs, connects a country to the digital world. I'm trying to get to the next standard, but next slide, but I can't do it. So. Okay, so why use the DRM standard? I gave you some reasons. First of all, as I have already mentioned, it gives more than audio. That's the main difference between digital and analog. Digital radio is a new platform, really. It gives you data, which is available a lot on mobile and internet, but it bolts it onto audio and the radio. So it gives information, news, entertainment to people wherever they are. Because sometimes people say, but I get radio on television. Yeah, you get it, but you won't be able to take your television set in the car or in the field and see and listen to the radio. I made a point about the internet, and there is a point which resonates in some countries more than in others. When you are on the internet, you already have introduced yourself. You are identifiable. In radio, you are not, because radio is one to many. Anyone can listen to the radio, and you are anonymous. You don't have to be a number. And radio, digital radio, as I said, a new platform, audio, multimedia data, and also the possibility of catching information, storing information, and playing it at the right time. Again, I'm coming back to education. How useful is this, especially now in COVID times, if you can store the information and play it the next day like you would write something on a blackboard for children. So I make the case again, I hope it's strong enough, that digital radio, DRM, is the real integrator and the universal provider of education, information, and emergency warning. As we like to say, somebody in my office always says, digital radio never leaves anyone behind. And with that, I think I will go to the countries that are rolling out DRM. As you know, India is the largest digital radio rollout in the world. You will have seen many presentations on this, and you can ask questions on that. I hope you can hear me. I'm getting a message saying that my internet is not that great. China has deployed shortwave domestically in covering the whole country. Pakistan is preparing the rollout in FM, which is very interesting, and also later in medium wave and shortwave. And Indonesia is again looking at DRM very seriously, especially for its emergency warning functionality. I have put there some more some more countries. You can look at them, because I would like to talk about other countries that maybe you haven't seen. Oh, sorry. What am I doing? Well, I didn't want to get that far, so I'll go back. Sorry about this. That's just a preview of the next segment. But I wanted to tell you also about the other countries that are looking at the moment at DRM or employing it. For example, Hungary is doing shortwave and the shortwave transmissions have got as far as. Sorry, our presentation is see. Sorry, Alex, I'm trying to encroach on your. Okay. So we mentioned India, Pakistan, Indonesia, and other countries interested like Bangladesh. I was telling you about European countries, Hungary doing shortwave, and the signal reaching from Budapest up to the Netherlands in The Hague. I would also like to mention that the data capability of DRM has been proven in the United States and has been shown to work for the French Navy, as well as nowadays being used by the German Navy as well. So there are other possibilities for DRM apart from the audio. You can see now the slide, and I have left at the end Russia because, as you probably know, Russia is doing at the moment DRM shortwave from Siberia, covering a large part of Asia, and has tested DRM in FM in St. Petersburg. There are countries in the Middle East that are broadcasting in DRM, like Kuwait, and there are other countries or other transmissions you have heard, like BBC World Service from the UK in DRM to Europe and India, or Romania, which is doing a lot of DRM transmissions. We get a lot of recordings from Latin America, from Radio Romania International. So that's a very broad view of DRM and its global capabilities. I'm not touching my screen anymore, and I will pass the control to Alex to remind you of what is actually the DRM standard. Thank you.
Thank you very much, Alexandra. So let's have a quick recap. Basically, everybody has seen the slides already. That's good. We can be faster. What are the key facts? Well, DRM is an ITU standard for terrestrial digital radio. It is for all coverage needs, and that's quite unique as a digital radio standard. It covers everything from local and community services all the way up to international transmissions. So all the use cases that you might need for the different layers of coverage in your country can be accomplished with a single standard with a common feature set and functionality for the listeners. In every single transmission, even in the AM bands, you can have multiple audio services, up to 3, plus multimedia and data components and services. It is a digital-only signal, but it can also operate in simulcast mode, meaning that in medium wave, technically even the FM band, you can, from a single transmitter, broadcast both the former analog signal and the new digital signal on the site. In medium wave in particular, that's a very efficient mode of operation, particularly for the transition period, as India is demonstrating with almost all of their DRM transmissions at the moment for most of the day. The one important aspect for the transition is also that existing infrastructure can be upgraded quite easily, depending, of course, on the model of transmitter. But in any case, you can keep the sites, the antenna installations, the distribution lines, all of that remains in place when you upgrade from analog to digital. DRM is also designed to work in the frequency bands that have been internationally assigned and coordinated, so it doesn't require new coordination. Very important point. A real true successor of analog AM and FM technology. It is openly standardized and published, which means that while the DRM consortium is taking care of maintaining the technical specification of DRM, it doesn't own it in the sense that you as a manufacturer would need to approach us for a license or asking for allowance to build equipment or getting especially confident source code or something. All of that is publicly available, not controlled by a single company or organization. So everybody can start building equipment without asking for permission, meaning asking for a license. It is not a multiplex solution as such, even though you can do up to 3 services per transmission, but it is not a wideband multiplex. So the goal of DRM is that as in analog AM and FM, every broadcaster stays in full control of their own broadcast signal. If they decide to do 1 audio service or 3, and what kind of data and what configuration, that's in full control of each broadcaster, not in the control of a separate entity, a network operator. Of course, it's technically possible to task someone else with this. Just to visualize the frequency bands from a single transmission, you have band 3, the highest frequency band, line of sight. The higher the frequency of your transmission, the smaller the coverage, but also the more reliable the coverage. So you know from your local FM services, that coverage is quite reliable, but it hardly spans beyond a bigger city or metropolitan area with a single transmitter. In the AM bands, medium wave, and in particular shortwave, you can get huge coverage, but the reception reliability might not be as high as with local FM services. But the huge benefits of the AM bands, meaning getting you that with a single transmitter, very efficient coverage of, let's say, a whole country as a backbone service, or in the case of India in medium wave, of the whole core areas of states with a single service, and now with multiple audio programs. That is a huge benefit. So we combine the benefits of the various analog bands with the new benefits that digital radio provides for services, data, advanced signaling, such as emergency warning functionality. To visualize how the transmission chain looks like in comparison, in analog, AM or FM, you had the program source, the studio, feeding that audio program over a long distance network to the transmitter side. In digital operation in DRM, you have as an additional core component, as Ruxandra mentioned, the DRM content server. That's the digital encoder multiplexer configuration center for the whole DRM signal, the digital DRM signal. It uses local contribution of all the audio sources and data sources, and of course the configuration interface. Therefore, ideally, the content server should always be part of the studio equipment. And the output signal of the content server is called MDI, Multiplex Distribution Interface. That's a plain IP-based distribution. So we don't need dedicated high bitrate audio lines or even analog audio lines anymore, which are very expensive to run. Any IP distribution between the studio and the transmitter sites can now be deployed, whether it's a microwave link, or whether it's satellite, or even public internet if you trust that service provider to give you a good enough quality of service. Any IP connection will do. I'm explaining that in a bit more detail because later on in the live hands-on session, we will use that this approach here, configuring the content server and seeing how it looks like on the reception side. So keep this in mind. This is a typical transmission structure for digital radio. What are the key features from a listener's perspective? Up to 3 audio services and multimedia on a single frequency that allows you to either address niche audiences apart from your main program, so to widen your audience altogether, or to have temporary pop-up stations. Let's say there's a big concert or big festival in your region, and you want to support that with a bigly advertised extra radio station, dedicated radio station. Educational service, information service over a data application, journal line, text information is another option. I already mentioned the option for simulcast. Audio quality. DRM uses the latest MPEG audio codec XHE AAC, which allows us to give you stereo services even on medium wave and shortwave transmissions, and in local FM services up to surround sound. Something you may up to now only know from the cinema, maybe your home theater installation. Multimedia applications we will have a look at in more detail in a second. Good coverage. Digital radio offers whole new approaches to covering a region, and Simon will give us more information about that later on. Instead of the classic approach, where a single high-power FM transmitter is erected in a city to cover the whole city and to reach the difficult spots, you have to over-exponentially increase the power of that one transmitter. DRM has a better approach where you can have low-power gap fillers anywhere in the area, and all of these transmitters work on the same frequency without creating interference, actually improving the signal quality even in the overlapping areas. So whole new approaches of planning your network and saving additional lots of powers in that approach. In general, you need a lot less power. We will talk about that also in more detail later on. You can save up to 90% of transmission power. And as you know, as a broadcaster, that is a very significant part of your budget to run your transmission networks. Automatic tuning means convenience features for the listener. You don't have to memorize frequencies and bands. You just select from a list your station by name and by graphic logo. And then it's the receiver's task to keep that service tuned as long as possible, even if that means in the background switching between different bands and frequencies and distribution standards even. Finally, emergency warning functionality, a key element, as Ruxandra mentioned, for many countries. Whenever there's natural disasters pending, even in the cases of immediate outbreaks, and this is where DRM can help with information, with alerting people, with making them in the loop, even those people that don't have necessarily internet access, if they are blind, if they are deaf, all of these special groups of people can be served with emergency warning functionality in DRM. So let's have a look at the multimedia applications in a bit more detail very quickly. There's a handful of standardized data application. On top of those, as a broadcaster, you could also do your own defined specific data applications. For example, Ruxandra mentioned the demo where, or the service where maritime ships somewhere on sea are served with information through DRM, using DRM as a plain data channel. That would be a specific closed service solution for data transmission. These samples here that I mentioned here for multimedia applications, they are standardized, and therefore those are the applications that the broadcasters and receiver manufacturers have agreed on and can rely on to be supported in the receivers and in the transmissions, at least most of them. DRM text messages are the scrolling text, the current program title of the audio you're listening to. Journaline is the more advanced text information and interactive service where you can look up detailed articles and information focusing on various topics in a menu structure on your receiver device without the need of any internet connection. All of that is provided through the DRM signal. Slideshow is a service where you can transmit images, for example, accompanying the news or the album cover of the song that's currently played. That requires quite a bit of capacity, so that's a typical use case for local services in the FM band. SPI is the service program information where we can, above all, transmit the station logos to the receiver. So if you have an update to your station logo, don't worry, you can just put it on air and all the receivers that support graphical station logos will pick it up and update their service. TPEC and traffic information is, again, something typically reserved for local services. It doesn't make sense to broadcast the road conditions of Delhi over shortwave to the world. There's a great benefit in those multimedia applications, both to provide additional information by public broadcasters and community stations, but also for commercial stations to really dive into new ways of creating value and also revenue for their station, apart from the on-air announcements that we know from classic radio. Emergency warning functionality, let's have a look at how that works now. The principle is that we want to reach the widest possible number of people using the established radio infrastructure and devices, radio sets, which are everywhere available and used for other purposes during regular times, so they're non-intrusive. You don't need to buy extra equipment, and reach as many people as possible, meaning that we want to include travelers, people that don't speak the local language. We have to consider people that are hearing impaired. How can we get the information to all of them? And the good news is DRM has all these tools built in as a default feature of the standard. It's called EWF, Emergency Warning Functionality. The way it can help in cases of disaster are mentioned here. Typically, you have preparatory information, general education, when there's an earthquake, children have to hide under the tables or in the doors, in the door frames. All of this information is general information that you can make available to people, even if they don't necessarily have daily access to internet. At least they would get this in their own language. Once a disaster is detected, let's say a tsunami is rolling in, you can instantly send out the warnings and dissemination of information. That is supported by an explicit alarm signal, which even can help to switch on the radios. Let's say while you're sleeping at night and you have your digital radio in the neighboring living room. Once there's an alarm, it can switch on, go to full power and volume, and wake you up, give you that crucial warning. Then after the disaster has hit, there is the immediate crisis support and rescue support, and finally the post-disaster services, bringing together lost family members and all of that. All of these elements are supported by digital radio. So how is that done? That's a graphical description how DRM emergency warning functionality works in principle. You have a green area, that's a territory. You have the bright green, yellowish area that is affected by that particular emergency. Let's say it was an earthquake. And the local infrastructure may or may no longer be available. Local power supplies, local FM transmitters, the mobile networks for social services. People always say, well, if there's an emergency, I get it on my phone. That's true, as long as your phone is still working, the transmitters are still there, the infrastructure is still there, and as long as, depending on the type of crisis, the mobile networks are not deliberately switched off, as we saw, for example, with the Boston bombers many years back, where as a first measure, the authorities decided to switch off all mobile communication to prevent further spread of misinformation, but also, of course, the bad people to use that network. So don't rely on all these sources individually. The combination of using all the tools and all the distribution methods to reach people is what really makes it a useful infrastructure. Another benefit of DRM is that people trust the information given over radio much more than they do social media these days, because this is typically from authorities that have first-hand information and that have well-researched and proven information and make that available. So once the emergency has hit, local infrastructure may not be available. You can even reach from outside the area to serve the people. That's one other benefit of radio. You have the potential for longer distance coverage or even FM band coverage from outside the affected area. And then once the receiver switches on, automatically it switches to that emergency program. It brings up the text screen where you can then first select your own language and finally find out what's going on in detail. With this combination of audio presentation and journal line-based text information, we have achieved the goal of serving the widest possible audience, as we can reach regular radio listeners, we can reach non-native speakers, people traveling or tourists or foreigners in different languages. And finally, with a flashing screen and then the textual information, we can reach people that might be hearing impaired. So all of that is covered. And the combination, therefore, really gives us the value of emergency warning functionality. Let's have a quick look at how it looks in practice with a live FM transmission chain that we set up for BES in Delhi in February.
Transmission. In this case, we have a special functionality as well to show the emergency warning functionality. So we have a button, and when I press that button, the signaling of DRM is used to create an alarm, which shows that as well as the receiver, they will show information of the current emergency on air. The button normally is not pressed by a user, but that's normally a government institution that is organizing when such an emergency alert via broadcast is sent out. Now, if we've ended the emergency alert, and now we can have a normal broadcasting situation again.
For those of you who attended last week, there was a detailed description of emergency warning functionality by Mr. Pahl. If you want to find, so you will find it in the distributed documents. But if you want to find out more, just look at the DRM handbook, or in general, the drm.org webpage, where you will find more information. And with that, I hand over now to Simon Keynes. He's talking about DRM and how to apply it for large area coverage.
Thank you very much, Alex. I appreciate the introduction. So I have been asked on behalf of Ampegon to come to talk to you about large area coverage using amplitude modulation in the AM bands. Now, DRM is the only digital standard that is harmonized for all broadcast bands. So you can see this is circled on the screen right now. The frequencies in the long wave band, 30 kilohertz to 300 kilohertz, the medium wave band from 300 kilohertz up to 3 megahertz, and also the shortwave band from 3 megahertz up to 30 megahertz. So Alex will talk a little bit about the VHF bands and the FM bands later on in the presentation, but I'm going to consider solely the AM bands. So DRM is very, very useful for the amplitude modulation techniques because this excels at long-range broadcasts. So this is for medium to large range coverage. So from country to international distances. So one of the big problems with amplitude modulation techniques in analog mode is the fact that you only get a mono signal. So you get mono sound, which is obviously very, very much lower quality than FM. However, with digital signals, we are able to get FM-like quality sound. So we have stereo broadcasts, and you don't receive the atmospheric effects of cracking and fading and distortions that come from variations in the ionosphere and disruptions to the ground wave and the sky wave. DRM is, as discussed previously, the only standard for all amplitude modulation bands. It's ETSI ratified and endorsed by the International Telegraphic Union. And all of the planning parameters are available from the ITU, and there's an awful lot of information for you online on our website, drm.org, about how you can set this up. The amplitude modulation bands have worldwide spectrum compatibility in DRM, so it accounts for the 9 and 10 and 18 and 20 kilohertz bandwidths that are standardized. And with the data rate of up to 72 kilobits per second, this is a very, very useful amount of data to use. Now, it's never going to be as good as the FM bands because they have a greater bandwidth, but for something that can reach out internationally, 72 kilobits per second is very useful. So this all provides us with a flexible configuration. You have a robust network, so you're broadcasting to an entire country from just one site or maybe a couple of sites in the case of larger countries, which provides universal coverage to people regardless of where they are. They could be in the cities, or they could be in low population density areas in the countryside, or even in deserts, jungles, wherever. Of course, this requires transmission power. If you're broadcasting to the whole of your country from one site, typically the transmitters are more powerful. But as we'll see with DRM, this is a significant benefit because you're able to reduce the transmission power thanks to the error correction. And of course, as Alex previously mentioned, you're able to cover large areas using single frequencies, using single frequency network function, whereby if the receiver detects that the signal strength from one transmitter is falling, it will automatically switch to another transmitter, which has a greater signal strength wherever you are. So let's have a look at the energy consumption, because this is an important part of the benefit of the DRM digital standard. So here we have a typical analog broadcast. You'll see in the diagram to the top left of the screen, you have the carrier wave being modulated, and then the sound that is broadcast will be modulated on top of the carrier wave. It's convoluted together to give you your signal output. And so in the bottom, you can see the majority of the energy that's necessary is for the carrier. This has no content and accounts for 66% of the energy emitted from the transmitter. All of the data, all of the content, all of the sound that you have in an analog broadcast is carried on the upper and lower sidebands. And this only accounts for 33% of the energy and is providing the information that is played through the speakers of your radio set. Now, the carrier wave is just there to make sure that the reception level of greater than 47 decibel microvolts is received by your receiver, which is the international standard for a good signal. So using DRM, we're able to actually reduce that power, and the carrier wave is not actually necessary for the digital data to be transferred. And so essentially, if you have a transmitter covering a 300 kilometer radius area, so 235,000 square kilometers, for example, for a single channel, by removing the carrier wave and operating in DRM digital mode, you can reduce the power of that transmitter down to approximately 40 kilowatts. So you've got a 60% energy saving to cover the same area. Now, this is the calculation of the DRM consortium. ITU has done their calculations independently, and they suggest that the necessary field strength is received by the receivers only using 20 kilowatts of power for that 235,000 square kilometer area. Now, I think we can all agree that that is significant saving, but of course we're talking about RF power there. So if we actually look at the efficiency of a typical transmitter, of course you're putting more energy in than you have coming out due to the laws of physics. And so you can compare the energy, the electrical energy necessary as such. With one service in analog mode, you need approximately 142 kilowatts of electrical energy, whereas with the DRM calculations, you can get 1 to 3 services, as previously mentioned, plus all your multimedia functions and the emergency warning service, which is only requiring 50 kilowatts of energy. So this is almost 1/3 of the amount of energy that would be required for a single analog channel. And this reduces the operational costs and makes DRM a green technology. Now, the obvious benefit of the amplitude modulation techniques is the distance that they are able to broadcast using skywave and ground wave techniques. Now, if we take our same transmitter, we're operating in medium wave, remember broadcasting FM quality sound, 3 audio programs and the data channel covering a radius of 300 kilometers, so diameter 600 kilometers as you see on the screen. You would need a minimum of 15 10 kilowatt FM channels just to provide broadcasts over the same area. And even then, as you can see, you'll have gaps in between, and you're going to have fill-in networks that are broadcasting to everybody that's covered by the medium wave transmitter. So you can see by simple calculation, 15 transmitters running at 10 kilowatts FM compared to 40 kilowatts of DRM, you're looking at a significant energy saving, and you don't need anywhere near the amount of infrastructure that you need for FM transmitters. So while maybe this is not necessary in cities, for large countries with low population densities out in rural areas, this is absolutely a benefit because we are able to save power, we're able to reach everybody, and we're able to do so with significantly less energy than before, whilst maintaining a better quality service than is currently achievable with analog transmissions. Just so that we can put that into a map, it's all very well looking at little graphics, but what does 600 kilometer diameter footprints actually look like? Here we've put some transmitters in Kuala Lumpur. So there's an FM transmitter with a 75 kilometer footprint diameter. Assuming they have an FM transmitter in the city, I'm sure they do. But if we have the same transmitter location in medium wave, broadcasting once again up to 3 FM quality services, instead of just covering the city of Kuala Lumpur, you are covering the whole of mainland Malaysia, also part of Indonesia, and also up to Thailand in the north. So the reach of the amplitude modulation transmitters gives it a significant benefit over that of FM, so to make up for the poor data rate and the additional time it takes to load all data, etc. Similarly, if we look at shortwave, we can go even further with very, very little power. So here we have a simulation done for a 10 kilowatt shortwave transmitter put into the country of Myanmar, ideally placed in the center to try to cover as much of the country as possible. Now you'll see that the ITU recommended field strengths necessary are indicated for analog would be the red area, which is right in the center. So you might get good coverage for an area of perhaps a city. However, you're going to get areas within the rest of the signal strength map there that is in yellow that is going to be possible to get the good signal. However, it's still very, very small when it's operating in analog mode. However, if you go to DRM, there is a lower field strength requirement, and therefore the signal goes further. So you're going to cover the entire of the country of Myanmar with a single 10 kilowatt shortwave transmitter. Once again, FM quality sound and data applications as well, and potentially you can get reception all the way from China in the north to Thailand in the south, from Laos in the east, and India and Bangladesh in the west. And this, once again, is for 10 kilowatts of power. In FM, this would cover an entire city. In shortwave, it covers most of Southeast Asia. At this point, I should mention that we have an interactive shortwave broadcast schedule online tool that is able to show you where and when all of the shortwave transmissions are going on and the target areas that they are broadcasting to. If you go online to schedule.drm.radio, you can find that website and play around with it and have a look at what you could hear in your area. So one of the things that came out of the previous webinar series last week was that there was a lot of questions coming through about simulcasting, which is the simultaneous broadcasting out of a transmitter of both an analog and a digital signal. So most modern transmitters these days, medium wave and shortwave, are capable of broadcasting over 20 kilohertz of bandwidth, which means that they can cover two adjacent channels and then broadcast one channel with an amplitude modulation analog signal and the other channel on one sideband, either on the upper or the lower side, with a digital signal. Now, how this is done is relatively technical, but there are options to do this over 4.5 kilohertz, so a half channel, 9 kilohertz, a full channel, or 18 kilohertz, a double channel, depending upon your requirements. And this will allow the transition from the analog signal to the digital signal over a period of time, if necessary, from the same transmitter. So this means that nobody gets cut off. Suddenly they have analog signal one day and the next day their analog radio can't pick up the programs that they're normally listening to. Now, the recommended rollout program would be to have multiple transmitters, some of them working analog, some of them working in digital, which again is also facilitated by the fact that each digital transmitter can pick up the slack from 3 analog stations. But if that's not possible because of lack of infrastructure, for example, you can use a modern transmitter with this simulcast functionality. There's a little bit of data here about how this is done in real life. This is an All India test, All India radio test that they have been doing over the past weeks and months and years. And they have been playing with various different options. So playing with the upper sideband, which is the ringed in green on the top of your screen, and also the lower sideband on the ringed in green on the bottom of the screen. It's rather technical, but there's an awful lot of information in the DRM handbook, which will be updated next month. So you can go to the website, download all of that information, and there's pages and pages and pages of data and explaining how it all works and how it can be implemented in your country. So just to conclude quickly, the DRM standard is applied in the AM bands as well as the FM bands, which is the optimized system for wide area coverage. AM band is good for long distance, FM is more localized. And it's relatively simple to upgrade to DRM using AM. If you have existing infrastructure, there's no need to renew it all. Modern transmitters can all be upgraded, and this secures long-term investment in the existing transmitter networks, so it gives you a chance to apply for funding to keep all of these working. The significant benefit here is the energy saving that is possible. Typical medium wave and shortwave transmitters go up to 0.5 megawatt or more, and so saving 60% of the energy there significantly reduces your operating costs and helps save the environment because, of course, you don't need as much electricity. And once again, each of these enables analog AM services to be upgraded to digital services with 1 to 3 programs, error correction, all of the data, the journal line system, the emergency warning function. This is a massive, massive technological increase over the previous fadey, crackly, subject to atmospheric conditions analog services that a lot of people in the world are currently receiving. Of course, this also comes with additional benefits. There's lower cost for maintenance. You'd need reduced numbers of spares. And if you were to buy an analog transmitter today, the vast majority of them are DRM ready and only need an upgrade at a later date with a plug-in module that goes into the rack. So, all in all, I think I have tried to stress to you the benefits of using DRM for your AM band transmitters. And I think now Alex will take over from me to talk about local and regional coverage using FM. So, thank you very much.
Yes, thanks a lot. Can you hear me? Yeah, good. Now let's have a look at the other end of the spectrum where we want to serve communities and listeners in a local or very regional infrastructure. That, of course, lends to the VHF bands, which should be or which are ideal for this kind of coverage scenario. So this is the reminder. DRM has the same functionality feature set throughout all the bands it supports. But now this session will focus on the local regional services above 30 megahertz in the VHF band, particularly FM band 2. But DRM, as you know, can also be deployed in band 3 or in band 1. In either case, DRM plays very well with the existing transmissions there, whether it's analog FM services or if a country has already deployed DAB+ in band 3. All of these scenarios can be enhanced with DRM services. In general, the parameters, the optimizations for DRM in the VHF bands have also been endorsed by ITU. There is both the system description available, but very important, also a whole document on planning parameters. So when you start planning your national rollout and coverage, those planning parameters to insert into your planning tools, these are all available with ITU as well for DRM in the VHF bands as much as the AM bands. The bandwidth is fixed to 96 kilohertz or 100 kilohertz nominal, which is half the bandwidth you would need for a single FM analog station. While DRM, of course, can give you in that same bandwidth 96 kilohertz up to 3 services plus data. To give the technical people among you an idea, if you compare it with internet streaming, that gives the 96 kilohertz, depending on the chosen configuration and robustness of the signal, gives you between 37 kilobits and 186 kilobits per second of capacity for your audio and data content. That kind of trade-off, the flexible configuration between capacity, the achieved coverage, and the transmission power you choose, that is one of the great strengths of DRM because it can adjust easily to all the individual terrains and coverage scenarios. In any case, it's green and efficient. We will have a look at that, what that means. The majority of energy efficiency certainly coming from the approach of digital transmission, as we already saw earlier. It is compatible with the existing FM band and regulation, as well as with the existing FM infrastructure. So if your country wants to roll out and establish DRM transmissions in the FM band, You can use exactly the same sites, the same distribution lines, again, the same antenna installations, all of that remains. And in band 3, as I mentioned, it's fully compatible with existing DAB+ services, so or in band 2 with FM services. I mentioned the flexibility. This is just to visualize it. In this graphic on the left, you have the various code rates, meaning the level of protection data versus useful data, how much of your capacity you want to spend for extra data that helps to correct reception errors in the receiver. Of course, the higher the amount of protection, the lower the capacity then for useful data, but the more robust the reception in critical coverage scenarios and conditions. That also reflects nicely at the bottom of the graph, where you can see the various SNR levels that are required, the signal strength and signal to noise ratio at the point of reception that you need to achieve to receive that signal. If you have a very robust signal, that's the lower left square dot in the 4-QAM blue shape. That's the most robust configuration. That only gives you 37 kilobits per second data rate, as the lower bar shows. But the bar below shows the benefit. You only need about 4 dB SNR. That is a very good value to receive the signal reliably, even in critical conditions. On the other end of the spectrum, if you have a very easy terrain to cover, you can reduce your transmission power, but you can also choose to go for a more relaxed and data-oriented configuration of the DRM signal. In this case, the maximum capacity is achieved with 186 kilobits per second if we use the operation point in the right upper right corner of the 16-QAM configuration. But that, of course, then requires a slightly stronger signal at the point of reception to be fully received. So this kind of trade-off is something that gives you great flexibility to optimize your particular transmissions and network planning for your individual requirements. I mentioned the green and efficient part where you can save energy. What does that mean? How does that translate? According to the ITU values for stationary reception, the coverage area achieved with a 10 kilowatt FM transmitter with one service and a bandwidth consumption of 200 kilohertz in the FM band, that same coverage can be achieved with about 1 kilowatt of DRM transmission power. So you can save 90% of your transmission power. That's even more than in the AM bands. Of course, that depends on your terrain and the configuration that you choose. Maybe it's half a kilowatt, maybe it's 2 kilowatt, but in that range. However, in any case, that gives you the DRM signal in that coverage area, then gives you, as you know, up to 3 audio services plus the data. If you want to find out more detailed calculations, all of that is available in the DRM handbook. If we turn that around and say, okay, our transmission power, our budget is available and fixed, what would it mean if we switch from analog FM to DRM, keeping the same transmission power? And we did the calculation. In this example, there is 1 kilowatt ERP for both DRM and FM on a certain FM frequency in Germany, in this case, in the city of Mannheim. The green dot in the center of each graph, that's the coverage of the city center of Mannheim. That's what you can achieve with 1 kilowatt analog FM. The white area, the white calculated area, that is the coverage that is served by the DRM signal. If you just switch the same transmitter, same power level over to DRM operation, to digital operation. And the 3 different graphs are distinguished by the use of application. In the first case is fixed reception. That would be a stationary radio sitting somewhere. The next middle graphic is in the portable indoor handheld, if you have DRM built into your mobile phone and carry it around your home. And the right graphic would be mobile outdoor. That is your typical car radio usage case. And what we did is to make it more comparable. The white area was then transformed into a circular area. That's the red circle of the same area, so of the same space. just to give you an easier way of comparing the achievement. And the ratio between the coverage diameter of the FM service and the digital service, just by switching the modulation over, for the fixed reception is 6 times roughly. And for mobile outdoor reception, you can actually increase your coverage area by a factor of 10 with the same transmission area power. That's this graphic. Now, how can we insert and start broadcasting DRM in the FM band? We already have FM services there, that's true. The beauty of DRM is that it is an independent digital signal, even though it can be simulcast, technical simulcast with an FM service from the same transmitter, it doesn't have to be. So you're flexible to place your DRM digital signal anywhere in the FM spectrum. That's represented here. The service linking is done on a signaling level. So the receiver knows exactly, once it receives the DRM signal, where to find the same service in analog FM or in other DRM services in the FM band or even in the AM band. It knows about all of that, all these alternative frequencies, if they're properly transmitted by the broadcaster, and can then switch back and forth and keep that service tuned. So again, what I want to point out here is there is no requirement in DRM to physically co-locate analog and digital signals. And that really opens the door wide for innovative approaches to inserting DRM in the FM band. And we will see more about that in a moment. We already learned that DRM only requires, in the FM band, only requires half the bandwidth of an analog FM signal, and also for the same coverage area, it requires a lot less of radiated power. Typically, you want to keep one channel bandwidth of protection before repeating another service in the same band to give enough protection to each of the services. That means that even the white spaces in analog have to be wider than they need to be in DRM. However, DRM has another benefit here because, as we've seen from manufacturers, and there will be an example in a moment, and as you can see in this graphic in the lower right corner, you can have multiple DRM transmissions without any gaps side by side. So if you have enough spacing in your FM band available, if you have a gap somewhere of, let's say, 400 kilohertz or 300 kilohertz, 500, whatever, you can place not just one, but maybe 2 or even 3 DRM blocks side by side. And this is achieved by making sure that all of these DRM transmissions are transmitted from the same FM transmitter. So you have an FM band transmitter that has a bandwidth of not only 200 kilohertz for one FM service, but as a modern transmitter up to 600 or even 800 kilohertz of linear bandwidth. And we can use that to have multiple DRM services side by side transmitted. And the implication of that is that still every broadcaster is in charge of their own DRM signal in terms of content and configuration, because that's created in their studio, and then they send the MDI signal to this particular transmitter site. However, at the transmitter site, multiple MDI inputs, multiple independent DRM signals are combined and then transmitted from the same equipment and combined onto the antenna. So that means a lot of efficiency improvements here, a lot of energy and equipment sharing, bringing down the cost for each individual broadcaster quite dramatically. And both Notel and RF Mondiale, DRM consortium members, have presented that live at IBC in Amsterdam last September. You may say that, oh, but our FM band is completely crowded. There is no way to add another service in the FM band. And probably that's true, as long as you think in analog terms. This is an example of the FM band in Johannesburg, South Africa, where we did one of the first DRM FM band trials. As you can see, the band is crowded, and it is definitely true that you cannot fit another analog FM service and squeeze it into that band, just no way. Of course, without causing major interference for your own and other services. So there's no way to enhance that band, giving it more capacity. But if you look at the details of the spectrum, you see that there are gaps that can be used to squeeze in a half-channel bandwidth signal, and that is DRM. So DRM can be placed here with only 96 kilohertz in gaps that otherwise could not be used, which effectively enhances the capacity, the overall capacity of our FM band in these scenarios. And then if you look at the whole band, you will find that there are, in the specific example of Johannesburg, there are 16 such gaps available. You may not be able to see them very clearly, but there are these little red squares in the big spectrum graphic. And that means that you can squeeze an additional up to 48 services, programs into the crowded FM band. Now that's a very special situation in Johannesburg, where everybody's fighting for spectrum and the community stations are basically left out, while the commercial stations have a hard time getting a clear signal out. And DRM can help in all these scenarios really to give a proper service and make sure that the spectrum is used as efficiently as possible, and at the same time saving a lot of energy and cost to these broadcasters. In other countries where the situation is much more specified and properly controlled, it should be even easier to add DRM digital services for all those licensees that already have an analog FM license, for example, to make sure that everybody who has an analog license can also then start broadcasting in digital. An example of that would be in India. Another example where DRM in FM band was tested is in Batam. That's an island close to Singapore in Indonesia. So the island is part of Indonesia, it's close to Singapore. Here we have an FM transmitter site, and we converted that, it's a Gates Air transmitter, we converted that to using then a simulcast transmission mode of both analog and digital from the same transmitter without adding a new transmitter. The calculations are shown here. The calculations for FM analog 3 kilowatt and the calculations for DRM with only 300 watts for mobile use. As you can see, the coverage area is pretty much the same due to the fact that DRM requires so much less field strength at the point of reception. And then we did the actual measurements. How do these predictions match up with reality? And we were very grateful that both RRI, the public broadcaster in Indonesia, but also the regulator, Kominfo, and the other participants, even regulators from Singapore, took part in that. And we undertook several test measurement drives. You can see the route that was taken here. Basically, all of it is green, with one exception where there was a shielding from when we went through a valley, but otherwise complete green coverage, even outside the areas that were predicted to be covered by the digital signal. And then we took it a step further and drove further down south to a neighboring island, and even there we had perfect coverage until we had to really turn around. That was surprising to all the participants. The regulators, it was really eye-opening, showing the power of DRM in reaching the people reliably, even at very low signal strength, and that was proven in this case. So DRM could fulfill not only the predicted coverage, but actually, as you can see, went much further with fully reliable DRM services. The conclusion is, there was a simulcast put on air with an existing FM transmission equipment, no new equipment added, apart, of course, from the digital plug-in card to upgrade the transmitter. There was no disturbance on either of the FM stations nearby. We had very good mobile and indoor reception, and we could achieve quite a large coverage area in DRM mode beyond even the prediction. Now, looking at it from a practical application, you want to start introducing and upgrading your existing FM infrastructure and insert DRM services. This is a typical transmission chain on a technical level, from studio contribution, head-end, distribution, transmitter, all the way up to the antenna. In the case of DRM, we have one studio equipment that is added, the DRM content server, as we mentioned. That's the central element to encode the audio and configure your signal. It takes the content and then sends out the MDI multiplex distribution interface over low bitrate IP connection to each transmitter site. And then whether or not the DRM transmitter requires a band filter in addition, that really depends on the scenario, on the antenna and the manufacturer also. In all the recent trials, we could avoid the band filter because the DRM signal was falling off so steeply on each side. There was no issue with neighboring channels, even without a band filter. Converting an existing FM transmitter is straightforward and easy. This is an example of a Gates FM transmitter, the one we used in Batam, where you just slide in this DRM card into the existing FM transmitter, and you have the DRM functionality. So all in all, we saw that DRM in the FM band is standardized. You can use your existing equipment. It allows for additional network planning infrastructure, can save a lot of energy, and allows you to really be on air very quickly without much of an effort. And actually, currently, Indonesia is undergoing that process to install some DRM FM band transmitters, something that other countries have already done. Good. With that, I hand over to Simon to talk about SFN, single frequency networking.
Thank you very much, Alex, once again. So just to recap, we've had a quick look at the amplitude modulation and then also the frequency modulation techniques. But now we're going to talk quickly about single frequency networking, which is applicable to all of the bands that we've discussed so far. Oops, jumped over there, sorry. So single frequency networking using DRM, as mentioned before, is where two or more transmitters are transmitting the same content, i.e. the same data that's coming out in the digital broadcast, at the same time on the same frequency. Now, if you had an FM or analog transmitter doing this in the city or an AM analog transmitter out in the countryside, this would cause some problems. But for digital signals, this is possible, and it's actively encouraged because it offers benefits to the users. Now, the advantage is that the signals from multiple transmitters no longer interfere and destroy their signals, but in fact, they actually improve reception because you have a single frequency network gain. So essentially, the receiver is able to measure the signal strength coming from one transmitter, and if it notices another transmitter broadcasting on the same frequency, it can identify that, it measures the signal strength, and at the point where the alternate transmitter has a better signal strength, then it will actually switch over to that transmitter itself. And therefore, this allows you, rather than having to broadcast on different frequencies and have as high a power as possible, because once you lose your reception, you have to then switch over to another frequency and potentially to another rival transmitter for another company, then you are able just to have all of your networks on the same frequency, and then your radio will automatically switch as you move from one broadcast area into another. So this also provides ability to have cost savings, because you can run your transmitters, so you can analyze the service, and you can analyze how much power is necessary just to provide the coverage up until the overlap with the next transmitter. And it also allows you to put simple gap fillers into any areas that are hard to reach because of terrain effects or because of atmospheric conditions at a specific time, for example. So let's have a look at an example. We've got a transmitter that is somewhere in a country, and there is a city nearby and also some hilly terrain, some mountains perhaps. And when you have line of sight transmission from an FM or a ground wave from medium wave, for example, you will find that there is signal shielding that is provided by the terrain and by the buildings that are in the way, which are all absorbing the energy coming from your radiation out of your antenna. So you get gaps where reception is bad, or you can't even get any reception at all. So What you would do, therefore, is then if you have a neighboring transmission site, you can actually place an antenna and an emitter on the other side of the city and the mountain range in order to fill that gap that is coming from the original transmitter. So because there is then overlap, you are able to have the programming reaching everybody in the covered area, regardless of terrain and build-up areas. Of course, this has an additional benefit because should a power cut occur, or there's a natural disaster, an earthquake, a typhoon, something that takes out your transmitter site, the people who are in the overlapped areas would still be able to receive all of the coverage without retuning, without changing the channel, etc., without leaving your station. Because they overlap in the area means that they would still be able to receive the transmission from the alternate transmitter. Even if, for example, it was in an area that was stronger from the original transmitter, it's able to switch over to the alternate with slightly lower signal strength. But again, with DRM and the error correction, this is not an issue. So here we have a number of simulations that we have. The white area, these are areas in Germany that I believe were had tests. And you can see the effects of the terrain on the different areas that were there. So the white area is an excellent signal. The yellow area has good reception. With the red area has reception, but it's broken or with coverage interruptions, and the grey area there is no reception whatsoever. And this is using analog amplitude modulation medium wave. So you can see that they have to keep the areas separate, otherwise you have distortion, and where the areas overlap you have interference and problems. But if we switch this to a digital network, you can put everything onto the same transmitter. You're able to then have the single frequency network function in place, and meaning that there's no gaps between the coverage that are where the signals are interfering. So this allows you to cover with exactly the same transmitting power, exactly the same emission sites. You can cover a much wider area with the same programming without any problem whatsoever. So we need to know a little bit more now about the receivers that are available, because we can broadcast all the signals we like. So I'm going to hand over now to Jan and Radu, who are going to talk to us for a little while about the receivers that are available and how they work. Thank you very much.
Good morning, everybody. And I pass on, first of all, to Jan Bremer, Senior Product Marketing Manager in NXP in Germany, who is going to talk a little bit about the DRM receivers in cars. Yeah.
Yeah, thank you very much, Radu. Going to my first slide. Second. Yeah, so far we have sold over 2 million cars, or over 2 million cars are equipped with DRM receivers on the road in India. So that's a real success from many different car OEMs. I would like to give you a short overview. So we achieved that there are 1.5 million line-fit DRM cars in less than 2 years, so that's a real achievement. And the car manufacturers are not charging extra from consumers for the DRM receiver, so this is also very nice. Most of the Indian car manufacturers are either already installing DRM receivers in the cars or have plans to do this in the future. So the latest brand is MG, Motor Garage, with their model Hector. I will show you some details on later slides. And there are also more international car brands which have plans to add DRM in their cars. So, for example, Hyundai, here on this slide, you see a selection of models who already included DRM radio. So from low end to high end, Hyundai, the complete Hyundai portfolio here shown on this slide are already DRM radio equipped. So that's very nice. Also Maruti Suzuki, a strong car brand in India, for their high-end receiver versions. All of the Maruti Suzuki car models are fitted with DRM receivers. Here in the middle of the slide you see an example of a graphical user face for DRM radio. The Mahindra TUV 300 is also line fitted with a DRM receiver. You can see a picture of the car on the left side, and right you see a picture that has been taken inside the car of the DRM radio graphical user interface. Yeah, as already mentioned, a new car OEM selling cars in India with DRM radios is MG. Here you can see their SUV model Hector, and it's also equipped with a DRM radio. Next, I would like to play a short video that was taken during BES this year. 1 second, please.
So now we are with NXP, a company from Bangalore that is developing and implementing the DRM solution for digital radio, particularly for the automotive market here in Bangalore. And please introduce yourself and then what products you're presenting.
My name is Sushil Kumar Gupta. I am a program manager in NXP and responsible for DRM activities running in Bangalore. In the display, we have 3 products. This is a high-end solution for the DRM for automotive segment. We have a low-end platform for desktop radio to cater the market for the low-end segment. The third product we have is existing DRM receiver in the automotive in one of the Suzuki platforms, and we, with the software upgrade, we have upgraded it to receive the DRM in FM band. There is no hardware changes required. Just by having a software upgrade, we are able to receive the live reception in DRM in FM band.
Yeah, that was my colleague Sushil in Delhi this year on the BES.
So now we are with NXP.
So on the next slide, I would like to talk a little bit about our NXP software-defined radio solutions. So the nice thing is that our radio tuners are true software-defined radios, meaning it is easy to upgrade the radio to support new digital standards because they are all software programmable. So that means for all the car OEMs using our chips, it leads to a lean logistics and also to be future-proof. What does that mean for the DRM standard? So by a simple firmware upgrade, you can upgrade your existing DRM fitted radio, which was so far only compatible in the AM band, that it can be upgraded to support DRM in AM and FM band with no hardware change. So it's only a new firmware you have to upload. So that's very nice to be future-proof. So NXP offers a complete portfolio of automotive qualified DRM receivers for AM and FM band. For example, we have an entry platform that is based on 2 chipsets that we call the Atomic 2 and the Saturn solution, and the digital baseband processing is done on the Saturn. We have a mid-end platform, also again compatible for DRM in AM and FM band, that is based on the Hero chip and the Saturn chip, and also a high-end platform that is based on a Drm 3 and a Saturn. You can see here, for example, on the right-hand side, a radio board based on Saturn and Drm 3. Our latest chipset is a true one-chip hybrid radio, so It's possible to do AM, FM, and digital radio like DRM on one chip. This chipset is called Mercury, so everything is done on one chip. And what is very nice, for example, is we are currently working on a noise suppression solution for AM, because if you use radio reception in electrical vehicles, you have a lot of noise, which is distortion, causing distortion for your radio reception. And we have software. We are developing software algorithms to do noise suppression for the reception. So that is one innovation that will come from NXP. Yeah, that was my last slide. I would like to take over, that Radio is taking over. Thank you.
Thank you very much, Jan. It was very good. And actually the news that you gave us, that there are so many cars already on the Indian roads is excellent, because this has been achieved in less than 2 years. So 2 million cars on the road, especially that these radios are free of, they're not costing anything to the consumer, because they are installed free of charge. They're unlike in other countries in Europe, for instance, where you have to pay for an extra digital radio. Now, I would like to concentrate a little bit on the desktop receivers and the other solutions. There are here certain manufacturers which have been now are producing receivers like Gospel, Avion, which is very well known already in India, Starwaves, and Intot is also planning to produce a receiver. Then other manufacturers in Korea, for instance, RF2 Digital, Algo Korea, and of course Fraunhofer on mobile solutions as well. Now, Avion is very well known already in India, and we have this very improved radio set, which you can see here. I'm going to play a short video. We are actually running out of time a little bit, but what I want to say, and you are going to say it in all the, we see it in all the slides, is that these manufacturers have planned it, they produce prototypes, and they are ready for mass market production based on substantial orders. I'm going to come to this point a little bit later on. Sorry. No, there is.
Device from Uzbek, Avion, the Avion receiver. That is a design and a model created in India for India, with remote control available and full-featured. It has emergency warning functionality, it has journal line support, and now we learned this year that this model will get a major upgrade. There will be full support for DRM in all bands, meaning including the FM band, to be prepared for the launch of digital FM in India with DRM. We have innovative other features that will be added to this device. And hopefully we will even see a completely new price point.
The other manufacturer based in China, Gospel, has produced several receivers, and this, what you see here, is the first one they have produced, and again is ready for mass market production based on these substantial orders. It has got all the features of DRM in the AM and in the FM band. It has the latest audio codec, which is only today usable in DRM, the XAG AAC stereo, the journal line, the emergency warning functionality. Other new receivers are displayed here. There are various desktop receivers and also car receivers, one OEM and one aftermarket. Again, these receivers have all the features for DRM in AM and the FM bands, the journal and advanced text, the audio codec, the XAG AAC, and the emergency warning functionality. As you can see, there are various models of various designs. One car adapter, which is very useful for existing cars, has also been shown at the BES and has now a new version has been issued. again, with all the features of DRM incorporated. Another manufacturer is Starwaves, which is also in cooperation with a manufacturer in the Netherlands, Nedis. They have created several types of receivers which have all the features of DRM in AM, FM, the audio codec, the journal line, and the emergency warning. Again, I have to stress, they are all ready and they are waiting for mass market production based on these substantial orders from the various countries. I would like to play a video where the CEO of Starwaves, Mr. von Weissenhoff, presents his models.
Hello, everyone, and welcome to BES 2020. Please see the new receivers, the new range of receivers from Starwaves. Everything here is new, and everything that you see here is less than 5,000 rupees. So we have targeted the Indian market with affordable receivers, starting with the tuk-tuk radio. Tuk-tuk radio is something that you really can have in a three-wheeler or in a car, or you can install it somewhere in your house or wherever you want. It's a basic functionality. It works with a power supply. It can be connected to the car battery and can be connected to external speakers. It's done here. All the receivers from this table also receive DRM in all bands, so in the AM bands, including medium wave and shortwave, and in the FM bands. And next one is a small receiver here. It's a pocket receiver. Then we have different colors of the new Bluetooth speaker with DRM radio. Also, a water-resistant Bluetooth speaker with integrated DRM radio. This one can float on the water, so you can take it to your pool. And last but not least, a receiver from Nedis. Nedis is one of our partners, and we have developed this radio. This one was already shown a few months back. Everything else is new at BES. So price-wise, we're talking about something coming between 2,000 and 3,000 rupees, depending on the volumes for these smaller receivers, and between 4,000 and 5,000 for the larger receivers. But again, we can talk about quantities, and the price will come down with larger volumes. Another receiver is here. This receiver can also has a display to show journal line services, etc. Also, the other radios have an interface optional for Bluetooth that you can get the journal line information from there. Also, all radios include the emergency warning functionality. Hello, everyone.
Thank you very much, Johannes, indirectly, because I liked his presentation here. I'm going back to this slide because he mentioned pricing. So he mentioned 5,000 rupees and 2,000 and 3,000 rupees. Now, converted into US dollars, that would be, for instance, for 5,000 rupees, probably $60 or so. For the 2,000, 3,000 rupees, probably 25,000 and $25 and $35 roughly, according to the exchange rate. So he mentioned something very important again, which I'm going to mention as well later on, is the fact that you have to order, and you have to order mass volumes in order for the price to go down. Another manufacturer is Intot in India. They have receiver solutions for the automotive segment, also for the desktop receivers and the smartphone segment. I'm not going to go into the details. I'm going to play another video here, which is going to show the products they are talking about.
This is Intot, one of the very innovative companies in India. Actually, apart from winning so many prizes in India, they are also now the proud recipients of the DRM Enterprise Award 2019. And we just handed over the prize to Intot. This is Rajit. let's have a look at what the innovation is, what the news are for this year from Intot.
Hi, I'm Rajit. I work for Intot. We have different products of form factors in DRM receiver, supporting both AM and FM reception. This is one of our key products. This is for desktop radios. This supports both AM and FM reception in DRM. Also analog AM and FM. Also USB playback, file playback. And this is the automotive evaluation board, supporting both DRM and AM and FM band. And we have one in mobile, Android phone. This also supports DRM and AM and FM band. So we support customers, mainly automotive customers in the market. We are also looking forward to support desktop receivers.
Another manufacturer in the UK is Cambridge Consultant, and they are working on a prototype for an integrated DRM receiver solution which has a very low price tag. This prototype has been shown at the conference, Innovation Day conference in the UK, and this is a breakthrough for the desktop receivers because it's a small receiver and a very low cost and low power DRM design. Other manufacturers, as I mentioned, is RF2 Digital in South Korea. They have an SDR digital car radio solution. And another manufacturer for mobile phone solutions is Algo Korea, also in South Korea, and is in the process of developing a DRM for FM app for Android. Fraunhofer is working also on a DRM receiver solution with built-in Wi-Fi hotspots, which can be used in tablets and mobile phones, and it was presented during the PS Expo in 2019, last year, and I'm going to show a video.
2019 here in New Delhi, we are showing a live Drm transmission chain in the FM band, broadcasting from our improvised studio. Left is the content server, the audio encoder and data encoder for DRM. Then we have the transmission equipment here, feeding our live antenna, our transmission antenna in the back, and then receiving live with plenty of receiver modules at the booth, but most notably with a standard Android phone that has, without any hardware modifications inside, a DRM reception. For this particular model, we are using an external FM front end, an analog FM front end. That's all we need. These are available very cheaply in the market. And then we have the signal fed into the phone, and the whole digital radio reception, the processing, is done in software on Android. That software exists. It's working. We can switch between the different audio services of DRM, and we can even see all the data services that are being broadcast. The goal is, as the next step, once the policy is out by TRAI and the ministry about the digitization of FM band for the private broadcasters, including the private broadcasters, at that point, we will be renegotiating with the cell phone industry based on that policy to use the built-in FM front-end chips. So at that point, we don't need external equipment, we don't need any attachments. Every FM phone, Android phone, can then receive, with the right software, DRM in the FM band live. 2019 here in New
It was already mentioned by our colleagues in Starwaves, Mr. von Weissenhoff, how the prices are working. But manufacturers need to get clear announcements from the governments and regulators that the DRM digital radio will be launched at a certain date in a year. These clear announcements, these commitments of the government to roll out the standard are absolutely important, vital for the full confidence in such national rollout projects before the manufacturers actually can plan, invest, and produce mass market receivers, which should then also sell well, not sit on shelves. So the actual broadcasts proving that digital radio is a reality with all the benefits is also something that is needed before the manufacturers really trust and the entire project and can take large orders and start producing mass market radio sets. In terms of pricing, we as the consortium encourage and support any DRM manufacturer, but we as a consortium, as a not-for-profit organization, we do not produce ourselves such receivers, as Ruxandra mentioned at the beginning. We are not commercial, but we support commercial companies like manufacturers to create such receivers, to plan them and produce them. We believe also as a consortium that the local receiver manufacturing industry is the best way to keep the prices low. Now, prices depend solely on the volumes ordered. The higher the number of receivers ordered, the lower the price per unit will be, as is the case for any type of commercial mass market product. We cannot stress this often enough because we get a lot of questions on this subject. And if a price of a radio on the internet is at a certain value, this is not a product that has been mass market produced. It's a small volume, and hence the price is going to be high. However, if the local project managers of a national rollout work very closely with both manufacturers, distributors, and retailers around the table, then everyone is going to know what will happen next in the marketplace in terms of the rollout. So they all get the confidence that this rollout project is indeed happening. So once the orders are placed, the manufacturers are going to plan the production of receivers, produce them, and then sell them in big quantities. So that is what I wanted to stress here, that production of receivers and price of receivers are a key element in a national rollout project. And I hand over now to Alex, who is going to give you a very brief description of how to configure the content server.
Yes, thank you very much, Radu. Okay, this is a reminder of the DRM transmission chain in a simplified form, as we've seen earlier. You start in the studio with the data sources, audio, content, configuration, feed it all into the DRM content server. The output for the distribution long distance to each transmitter site is then MDI, multiplex distribution interface, over any UDP IP network connection. And at the transmitter side, the MDI is modulated and amplified and put on air. Now, the configuration of this DRM content server is done from any PC. The content server typically will sit in a rack, will be part of the transmission equipment, and you can just remotely connect to that content server from within your well-protected broadcast infrastructure and configure the broadcast with any classic web browser, HTML5 based. On the receiving side, we can use the same MDI signal and not only feed it into the DRM transmitter, but also decode it with an SDR, software-defined radio called the DRM Multimedia Player radio app. In that case, we can have full access to the live DRM content, audio, data, journal line, all of it, and see how it will be received and decoded in any receiver. That's very helpful, for example, for your editorial staff, but also for technicians who want to check that the right service logos are used, the service IDs and whatever, audio quality, all of these elements. The same MDI would also be used to feed into an archiving solution to take a recording of your on-air transmissions if there's a legal obligation, or for further monitoring options. And finally, when we talk about emergency warning functionality, typically apart from audio and data from the studio infrastructure, there's also then a path to the content server from the outside, from the authority in charge of defining when an emergency is severe enough to warrant an interruption and an alarm in the radio infrastructure. So we have a direct access to the content server, of course, highly secured and protected, where authorities can provide both the alarm trigger and also the content, text, journal line, and audio to be sent out through the DRM transmissions. A typical interface for that is CAP, Common Alerting Protocol. Now, what I want to show you when we switch the screen is that we have the content server web interface to configure the content server, and we have the multimedia player radio app running. And now is the time to switch. So what you can see now is the user interface of the content server, the start page. As you can see at the moment, all the elements of the transmission system, of the encoder system, are working fine and without errors. First thing is, I want to show you the configuration that is currently on air. It is called DRM ASBU Workshop EWF on air. Let's have a look how that is composed, how our DRM transmission actually looks like. So this is our DRM transmission. This the box in the orange with the orange bar. Orange means that this is the on-air configuration. So we have to be careful with reconfigurations in this particular configuration because it will immediately affect the on-air signal. What you can see is here that we have 1, 2, 3, 4 different DRM services. One radio program consisting of audio, text messages, and journal line. We have another audio program consisting of another audio, text messages, journal line. We have a journal line standalone data service, and we have already an emergency program on air for now for testing. And further down, you can see our configuration of the on-air signal. As I mentioned earlier, that trade-off between robustness and capacity. In this particular example, the configuration gives us a useful capacity of almost 150 kilobits per second, and we can then spread this capacity as we wish among those service components, the audio and journal line elements that we want to broadcast, that our DRM services are composed of. These are called service components. And the whole thing here is then one on-air transmission configuration called a DRM multiplex configuration. What I want to show you is the principal working of emergency warning. In this example, we already placed on air the emergency program, so we don't need to reconfigure our transmission. But now what we need to do is add the actual trigger. This would be coming from a central authority or source, as we said earlier. On the right side, you can see the DRM multimedia player radio app. That is presenting the live content that we are receiving at the moment, the services that I showed you earlier. I have disabled the audio to not interfere with the announcement. So we can listen to this audio, we can see the text messages, and we can have a look at the journal line. At the moment, there is some Fraunhofer news on air and some DRM latest consortium news on air, including the webinar that we are currently holding. So you can read about that in our DRM transmission. Now, what you will see is once I trigger the alarm as the authority on the broadcast side, automatically the receiver, whichever service I'm currently tuned to, will switch over to the emergency content and will present the emergency journal line on air, on the screen, so that I can listen to the audio and immediately access the text information that informs me about what's going on. So I'll click the activate button. Unfortunately, it is a bit delayed in this setup here. And once the activation is through on the transmission side, it will be signaled to the receivers, and you could see that our receiver now has switched over. So we are listening to the emergency alarm. We have a visual indication on the receiver that could be an LED flashing, for example, on a desktop radio, or some information on the screen of a car radio. And then I can find out about what's going on in different languages. Let's have a look. What is going on? What do I need to do? All of this information is presented right here, including information connections to find out more if I need to. And also the text messages then present the key information in different languages on the receiver. Once the emergency is over, as the authority, I can just simply deactivate the button, the alarm, and the receiver will at that point automatically switch back to the originally tuned service that the listener was listening to before. Of course, manually, a listener can always switch back to the previously tuned service and interrupt the automatic alarm at any time. Because keep in mind, in DRM, we are adding the alarm service. We don't replace any of the existing radio programs. So if you find out that the alarm is actually affecting the neighboring valley, you can always go back to your own preferred program if that service doesn't affect you. So one of the elements that we are broadcasting, as I mentioned, is this journal line information. At the moment, it's Fraunhofer News and DRM News. Now we want to add, in times of crisis, some information about what the World Health Organization has to say about the measures that need to be taken and the latest situation. To do that, in the content server, we simply switch to the service component editor. In the service component editor, we will find our own journal line service component. Just a moment. And that service component, the journal line service component, is which encapsulate the journal line itself and all the data sources that are combined to create this particular service on air. Now, what I did in the background is, let me go here. I switched to the World Health Organization, and they have plenty of news in RSS form available on their webpage. RSS is a form of syndicating news information. And for now, we are going with the overall news. Typically, that's just XML information, so it's not really useful in this particular web browser to look at. But in other browsers, you will have a much nicer appearance. What I can then do is, in the content server, I can just use that link, the URL that points to this RSS feed up here, and insert it into our transmission, and then have that part of the on-air service. And it would just show up as another information service with all the news listed up there. Another example is the text messages here. At the moment, I only set up 2 different text messages. This would be, in most cases, connected with the studio automation system, meaning that you take the automation information, the current song title, artist from your studio, and you present the currently playing song title and artist here for the consumer. In our case, we have an online editing tool as well for static information. So let's add something. What should it be? DRM is great, supported by ASBU and ASBU. So this will be another message. Keep in mind, DRM supports Unicode and therefore all different scripts that you might need. You can insert them here, whether it's Chinese or right to left script that we mentioned earlier. All of that is supported in DRM. In the meantime, I've copied the URL of the RSS feed. And in our service component editor, I have this journal line service component that we are broadcasting as RDB Young service with the 2 services sources, Fraunhofer News and DRM Consortium News. And what I will do is just add another content provider. I give it a name, WHO Health Update, let's say. and I choose as the import method RSS feed. There are different types of providing content, journal line content to the content server. And then all I really need to do is provide the RSS URL that we just copied from the web page here. I can click on test RSS feed to see if that information could be processed properly and is available and properly imported into the content server. And while we keep this at hand, I can then just click check and save. The system will make sure that all my changes are valid and consistent and store them back to the content server. So in the meantime, we can see here that the RSS feed has been processed and could be imported to the content server. This is how the content server sees that particular RSS feed. The import of our text message update was also successful. So now if we look at the sequence of text messages that are being transmitted, that includes our new text message, DRM is great, supported by ASBU and ASBU. So we put that on air without any effort, and this is how it works. But keep in mind, typically the text messages would be generated automatically through some playout system. And once the service components are stored back to the content server, then it will take some time and we will have the journal line enhanced with the World Health Organization news updates right here. I don't think we should take the time right now. There is some delay, obviously, with the processing. I suggest if you are interested as a consumer, as a participant in this webinar, we could have a dedicated session just looking at how you configure a DRM transmission, then also diving more into the details of what kind of signaling you need to provide, how a service ID is composed, what you need to take into consideration for creating your station service logos, and so on. All of these aspects. And of course, how to connect all these data inputs with your station automation system. That's an offer. Let's see if there's an appetite for that. And with that, I hand back to Roxandra. Thank you very much.
Thank you. Thank you very much, Alex. We are well over the time, but a lot of people were extremely interested. A lot of people have sent questions. I've started answering some of them, and we thank everyone for this. And I will just simply wrap up, saying that I think it was a fantastic seminar, webinar. We are continuing to get questions. Remember, we'll not answer more than 2 questions from one person. And with this, I remind you that you can become a member, you can get the newsletter, you can check on your net, you can check the handbook, which is on the drm.org site. Thank you for all your questions. Thank you to the panelists. I'm really sorry we couldn't ask them directly questions. They were all prepared to do it. But I'm aware of the time. I'm aware that very many of you have stayed to the end and have asked questions to everything. A lot of questions on receivers, on single frequency network, on everything that has been presented. Thank you very, very much. So,
thank you, Chandra.
Yeah.
Yes, I believe then we will close the session. The time, as you said, is not in our favor today. But let me, if I may, just before we close, the idea is that we will take those questions and prepare the answers, and we will share with everybody, if I'm not mistaken. Yes?
And before we just say goodbye, if you can go back, Nadim, and show the page where people can see the handbook, because a lot of the answers are on that. And with that, we'll leave it. If you can go back to our next, the other page before that.
Yes.
Please, please, please go to the handbook. A lot of your questions are answered. And as we said, we are preparing version 5 to be released in May or in June. And with this, thank you to ABU, ASBU, all of you. You are all stars, and all the panelists, to Alex, Simon, Jan, and Mr. Paul. And you will get answers directly from them. Thank you.
Thank you, Sandra, and the panelists. It was a wonderful session. I think you covered most of the topics that anybody will come across DRM in the last 2 days, 2 sessions. That's very, very helpful. As you said, of course, there are a lot of questions. We will prepare those questions with the help of the speakers, and we will distribute them to all the participants. At the same time, as Sandra highlighted, the DRM handbook, which has a lot of information, even more than what was presented here. And if you have any questions at any time, you are free to come back to us. Just drop an email and we will get the answers to you as well. With that, thank you for your participation over the 2 days. It's been wonderful. The attendance has been marvelous, and the interest you have kept in the presentation is great. So this is the end of this webinar series on DRM features and functions and the benefits, especially in the time of crisis. So before we leave, let me just introduce you to our next webinar, which is going to be on modern radio studio automation systems. This is a 4-part series starting next week, Tuesday, from 5th to 8th of May. Of course, this is also related to radio, so if you have an interest, we will be sending out invitations to all of you starting tomorrow. Some of you may have already received invitations. If you are interested, or if any of your colleagues will be interested in this series, do join us from 5th of May. Thank you again. Thank you all the panelists, Ruxandra. It was wonderful having you all. Thank you.
O organizador saiu da reunião. Esta conferência terminará agora.